Right, grade 12s, I want you to look at this example. It's going to involve rectangles, semicircles, circles. And what we've got here is a company that's designed a table mat or a placemat. What happens is this thing is put onto a dining room table where you have your food, you put this mat onto the table, and then you put your plates onto that placemat. Now, it's designed in such a way that they want the length to always remain at 100 millimeters for this rectangular mat, but they're saying that the width can vary, it can change. We're going to call it X, and what we do with this mat is we're going to take two white semicircles, half circles, and they're going to be pasted onto the mat there, and then what's left is a shaded area. And that shaded area is going to be multicolored. It could be gray like in our diagram here. But what we want to do is we want to, number one, find a formula for the area of the shaded bit here. And then what I want to do is I want to find the value of X for which the shaded area is going to be a maximum. Okay, now remember the length is 100 and the width is X for the rectangle. Now how do we get the shaded area? Well, it really simply is this, is the area of the big rectangle subtract the area of the two semicircles. What is the area of a circle? Pi r squared. If you halve it, you get a semicircle. But we're not really going to worry about pi r squared over 2. We've actually got two of them, so we're really talking about a full circle. So what we can do to say with the shaded area, very simply put, is that now, in A, if you have a look at this, we can say if you've got your rectangle, subtract the full circle, which is actually made up of the two semicircles. Okay, so what we can do is we can say the area here is going to be the rectangle minus the two semicircles. Now, the rectangle is length multiplied by the breadth. Okay, so it's 100 multiplied by the X. What is the radius of the semicircle? It must be X over 2, because that whole length, that width there, is X. So we're dividing by 2 to get the radius. Okay, because that's the diameter of the semicircle. And remember, it's two of them. So it's actually 2 of half pi r squared, which if you think about that is actually simply the half of 2 is just 1, is pi r, which is x over 2 squared. There we go. Okay, so this comes to 100x minus pi into x squared over 4. So in other words, your shaded area is 100x minus pi divided by 4 x squared there. Look at that. Okay, just make it into that form. They might say to you, show that the shaded area is given by this. That would be nice of them. I've worked it out. Okay, now, what must the value of X be, or what is the maximum shaded area here? What must X be for this shaded area to be a maximum? So all we do is we can say, well, okay, that's an unhappy parabola. It's got a maximum. Let's get the derivative. And if we differentiate that, that becomes 100. Careful now, minus pi over 4 multiplied by 2x. Bring down the 2, subtract 1. So your derivative is then 100 minus pi over 2x. Okay, 2 goes into 4 twice. Now, at a turning point of this parabola, the derivative is 0. At a maximum, the derivative is, of course, 0. Multiply throughout by 2. Let's get rid of fractions. We'll make life a little bit easier for us there. There we go. 200 minus pi x is equal to 0. And then let's solve for x. Okay, so let's bring that across. And x would be 200 over pi millimeters there. Okay, so that's the value of x for which the shaded area will be a max. How do we get the maximum area? If you want to get the maximum shaded area, all we do is we go in, we've got the expression 100x minus pi over 4x squared. That comes from the full-on area expression there. Okay, now all you do is you plug in that value of x into this, and you'll then get the maximum area. You've got the value of x for which the area is a maximum, and that's the shaded area. So this gives you 20,000 over pi minus pi over 4. Look at this. This is going to give you 40,000 over pi squared. Okay, so it's 20,000 over pi, and we can then see this gives you here, that gives you 10,000 over pi. Alright, and if you work that out, you're going to get 20,000 minus 10,000 is, of course, 10,000 over pi square millimeters. And there we go. That is your maximum area there. Okay,